Welcome, trailblazers and visionaries, to the Forging Manufacturing Podcast. I am your host, Dave Hampton.
And I'm your co-host, Jason Flores.
Forging Manufacturing's goal is always to provide insight and thought leadership to those working in, around, or simply just interested in manufacturing.
We'll bring you thought leaders who will share their stories of success and achievement, or stories of failure and how they've overcome, and hopefully we'll all learn something new.
Yeah. Ultimately, we just want you to walk away entertained and have a roadmap to better, whatever better means for you. And so last week, we talked with Jim Carroll and had some lively conversation about what is or was top of mind for manufacturing leaders pre and post-COVID. And if you haven't listened yet, I encourage you to do so.
Yeah, what a great following we have already. Really loving all the support that we've gotten and really appreciate all the listeners so far.
Yeah, absolutely. Yeah, thank you so much. And today we're going to be actually talking to one of those challenges that Jim Carroll was speaking about last week, and that's really around lean manufacturing and process optimization. And we'll be speaking with the president and CEO of ProModel Corp.
Yep. So Keith, you and I, Dave, you and I met Keith a few weeks ago. He's such an interesting, passionate guy. So I can't wait to talk to him further.
Yeah. And one of our old buddies and colleagues, Mike Joliker, is also now a ProModel, by the way.
That's right. Jolly. We all go way back.
We sure do. So without further delay, so Keith Vadas, president and CEO of ProModel Corporation. So Keith is an expert in developing and marketing predictive analysis-based solutions and has been driving the delivery of innovative solutions for over 30 years to more than 1,000 companies. He became part of ProModel when they acquired Simtech, a simulation and scheduling solutions provider Keith had founded in 1989. Keith's degree is in applied science and technology from RIT, Rochester Institute of Technology.
Oh, that's right. I forgot he went to RIT. That's not too far away from me.
Absolutely.
That's why I connect so well with him.
Well, hey, Keith, thank you so much for joining Forging Manufacturing.
Thanks, guys. Thanks for having me.
Yeah, good to see you, Keith.
Good to see you.
Yeah. So before we get into it, I actually have the two toughest questions of the day. So are you in Florida or New York, and how's the golf game?
I'm actually in Pennsylvania, and the golf game is mediocre.
Mediocre. Yeah, you're selling yourself short. I played with you. Keith pounds the ball.
Yeah, we actually had a board meeting this week, so I had the board members out on Wednesday. So it was a beautiful hot day.
Hey, so I'm curious. So if people aren't simulating their factory floor digitally, what are they doing? How are they figuring out how they can increase their throughput and examine different scenarios?
That's a good question. I mean, you can kind of see the evolution of things over many years, right? So I would say if you go back again 20 years, that most people, as they do still today a little bit, use spreadsheets, right? So you have a spreadsheet that says, here's my equipment, here's kind of the rates and times it runs at, and they do a really rough, if you will, static analysis. And other people, and still do it today, actually simulate in real life on the floor. So they'll go out and they say, well, we need to add a machine, or we need to move this over here, or we need to change, and they do it in real life. So they're literally simulating on the floor, but they're doing it in real life. Obviously can be extremely painful, because if you make the wrong change or you do the wrong thing, and you're starting over and over and over again.
We were talking to a manufacturer, and this has come up, I mean, many times, but the paper dolls, right? Where the people actually, to me, I almost have to laugh every time I hear it, because I'm like, are you serious? Some of the biggest manufacturers in this world are still cutting out cardboard or paper or whatever to put it down on their floor, and then they run their spreadsheet analysis and just to see if things fit there. And I'm like, are you serious?
Digital? Yeah, it reminds me of that movie, The Founder, where the McDonald's founder was developing a restaurant in a parking lot with chalk lines and running real scenarios.
Yeah,
that's wild.
Yeah, absolutely. That's still with Kaizen events and Lean Six Sigma. There's a lot of they still promote the old paper doll approach.
Yep. So can you help me understand a little bit? So discrete event simulation, it's been around. I mean, you guys have been around for a while, but ProModel's approach and differentiator. Can you talk to that a little bit? I mean, you did a little bit in your history, but kind of what kind of separates you guys?
Sure. So there, to be honest, there's a number of simulation vendors out there, and they're all, most of them are pretty good tools. I mean, it is what it is. At the end of the day, the tool is one piece to the puzzle. So it's not only the tool, but it's how you apply the tool and how you use it to actually make decisions at the end of the day. So, one of the biggest things that we try to strive right up front to people is, hey, you can certainly buy a tool off the shelf, but if you don't know how to leverage that tool, and leverage it a couple of ways. Number one, you certainly need to know how to push the buttons. So you need to know how to build the actual physical model, but you also need to know like what resolution you should be building a model. So for example, if I'm looking at a supply chain, a global supply chain, I'm certainly not going to build it down to the individual machine level at every facility. I might be building it at a cell level or a site level. If I'm looking at redesigning a facility, then I might be looking at it at the cell level. So for instance, when I say the cell level, a part goes into the cell, it takes, between, 20 to 30 minutes to go through that cell, and then it goes to the next cell. Versus if I want to go in and redesign the individual cells, then I need to get down to every individual machine, whatever it be. So teaching people up front kind of the concept of resolution of the model, and resolution of the model based upon what type of data you have or don't have. I think one of the things we hear the most out of people is that, hey, I don't really have a lot of good data, so I can't really use your tool. It's like, well, it's really just the opposite. If you don't have data, that's all even more important to use this type of technology, because the tool is nothing more than the calculator, the engine, if you will, that does the math for you automatically. If you try to figure out and get into complex processes where you have many different operations going on, and there's a lot of variability and a lot of risk built into that, how are you going to analyze it? Well, if you start with a spreadsheet and you put in some basic assumptions and you look at it, you could be way off the map up to what it's actually going to produce and how it's actually going to function and run. So the simulation engine, again, is just a way for you to be able to look at that and run it. So the differentiator, I guess, from our standpoint is not only selling, hopefully, technology that's great and easy to use and a lot of experience, but it's also the training of kind of what goes with that. And that's in the case of us training direct or training our trainers or whoever it may be. We feel that's a very, very, very important part of the process.
Yeah, I know manufacturers are collecting a lot of data. A lot of times they don't know what to do with it. And this certainly gives them the ability to use that data and leverage that data in their factory floor processes. The other thing too, as I remember, a while ago, FEA analysis was meant for just the scientists, and sort of got democratized over the years, and they can then, the users themselves, the engineers themselves, could actually start running some models in a precursor sort of fashion. Do you see this happening as well?
Absolutely. Like I said, I mean, back in the old days, this was kind of a science experiment for a lot of organizations. Now it's pretty much a widely adapted technology. In fact, what you'll see in the automotive industry and in other ones, that large organizations that experience using discrete event simulation specifically to do models of projects now are coming back and saying to vendors, hey, if you're going to be providing me a new system or a new line, you need to model it first. So you need to provide not only the proposal and the structure of what you're going to do, but you need to show me that it's going to work beforehand. So that has helped the adoption of the technology across most industries more and more. So our goal, again, is to continue to make it easier to use, so that, for instance, when they have a lot of data, that it isn't really painful to build the model, because there's not a lot of value gained in building the model other than understanding your process, which is, I should minimize that. That's a very important piece, where when organizations go through and actually construct a model of a process, it forces them to truly understand how that process works. And many times you get into a room with a bunch of people that work in that facility and say, here's the model of the process, and walk them through it. They go, oh, that's not how it works. And it's like, yeah, that is how it works. So it really opens a lot of eyes to how they're actually doing things now, or how they will be doing things, and then lets them get off the ego, if you will, decision-making process, and quantifiably as a group look at the results and say, okay, based on the results, this is the best course of action going forward.
Yeah. I like how you put that, the ego. Take the ego, take the gut out of it, right?
Right. Exactly.
Make business. So, and you're talking about the model, and I would like to go into, there's been a nice brewing, I'd even say it's more than brewing, partnership and developments that you've had with Autodesk. And it's pretty exciting. It's exciting for us. I'm sure it's pretty exciting for you. Can you talk to that, and why, how did this start up? And can you talk to the whole, not the process, but really where ProModel's going with the relationship there with Autodesk?
Yeah, it's very exciting to us. And, obviously Autodesk is a huge company, and they have a huge user base that play in the sweet spot where we play, which is in factory design. And from day one, most of the models that we ever built for any factory start with a CAD layout. It's the drawing of the facility. It is what it is. So it's either a greenfield new layout, or it's an existing layout, whatever, but it's always typically started with a drawing. And the way we did it, as well as any other simulation vendor did it, is you take that drawing as a picture. So it's literally just a picture in your software, and then you lay the model on top of the picture. So that helps you scale it. It helps you put in all the pictures as they look realistically on the floor. It helps them, the if you will, the consumers of the information understand what you're doing, because you're laying it across their layout. Well, with the connection and with the synchronization with AutoCAD and Autodesk, you don't have to do that anymore. Now, with inside AutoCAD, if people are automatically using the tool to do the layouts, and they're using their factory design utilities, or they're using their factory assets, they don't have to recreate that. All they have to do is go in and build your basic model on top of that already, which gives you the full integrated, dynamic, scaled version of a model right up front. Then they can, from there, take it and add whatever capabilities or modifications they want on top of it. They can even push it out to our high-end software, or keep it right inside AutoCAD. And then once they're done with that, they can then create a 3D view of it as well, very easily. And our eventual plan is to have then 3D animation as well on top of that. So that's just the starting point. I think what we're seeing now in Industry 4.0, and in digital twin, and the concept of the digital twin, as people are collecting data on the floor and tying data back into some type of a system that's tracking it, like what the Autodesk platform provides, you can then use that data to constantly refresh and update your models, so that you are now living with a living, breathing digital twin that has the latest information about how your floor actually runs. That leads to a whole nother world. Let me give you an abstract example. In healthcare, we've developed an application that models the hospital, but basically it links to their ADT systems that track patients flowing through the facility. So every hour on the hour, we can actually pull in the information of where everybody is in the hospital, and then run it forward for the next 24, 48, 36 hours to understand how the hospital is going to function. So they understand what resources and staffing they need, what the actual problems will be in the hospital, things like diverts to the emergency room. But even more importantly, you can also use that same data on the front end when you're constructing the models. So there's a lot of machine learning type stuff that we utilize to say, hey, here's historically how this thing ran for the last year or whatever. You can literally use that to automatically complete the basic structure of a model up front. So there's many reasons to tie to real data from the floor, but I think the future will be, hey, I've got to make a decision. I need a new part. I need a new product. We want to increase the throughput, whatever it may be. People will be able to go right to that digital twin, make a quick change, run a quick scenario, and then come up with the answers very quickly.
That's incredible. It's a great example too, and would have never thought about the healthcare side of things. But yeah, leveraging that data, and that's it. Jason, you said that earlier, right? There's so much data out there. and a lot of it's not being used. And it's incredible. I can't wait to see how this continues to develop with ProModel and all.
Yeah, you also, Keith, interesting to know, you started up a partnership network. You're sort of launching that. I'm happy to say Applied Software is one of your partners now. What's the reasoning behind that?
Well, we've been doing this for a while, and obviously the hardest part for us as a smaller company is to build a big distribution network of our software. And it's not distribution network just from having people sell the software, but it's people that have the capability, as I said earlier, to provide the service piece of it, which is very important. So we're really excited about partnering with you guys, with ASTI, because that's the type of people that will make our customers successful and their customers successful. So it's tying that piece with the technology piece, and the technology piece now is not just our software; it's the Autodesk platforms as well. And the more things that I've just been dabbling in this thing now with Autodesk for about 1.5 years, 2 years, and it's amazing to me that you go out and see all these customers that have these tools, but they're really not using the tools to their potential. So I think the advantage now that we have in working with guys like you and ASTI is that customers can now take advantage of the whole suite of tools that they have to be more efficient and be able to do things easier, better, faster.
Yeah, it's like the old 10-15% rule. And we see it constantly, right?
All the time.
Never tapping into the full potential. So a couple more things and then we'll let you go. I know, sure. I really do appreciate you joining us for a bit. So, change is hard for personal reasons, business especially, and manufacturers so fast paced and all. So any words of wisdom? You guys have been doing this, you've been around for a long time. For those that know that they need to optimize, those that know that they need to get started, but they have no idea where to start. Like how do you jump off?
Well, that's a good question. So most, if you will, really green organizations that have never kind of played with this at all, typically the way we've been successful with them is going and say, okay, where's there a spot that you really have pain with right now? Like what is one little part of your facility or operation, whatever, so that you could start by doing a rapid prototype of something. So it might be a cell, or it might be a line, or it might be something that you can go in very quickly. And when I say quickly, within a week or two, build a rapid model to start to understand, number one, what it takes to do it. Number two, what data it might take to support it. Understand the concept of resolution of a model, how you build a model, and show some rapid results to management. Because once they get a feel for, oh, that's really good, and that really helps us, and I can really see how I can use that going to the next level. Because then it will span. Where we see people fail is if they go in and say, hey, we want to model our whole factory right up front. It's like, yeah, that's okay, but don't bite off too much right up front. Start simple and build on what you built. So even if they're going to build the whole factory, start with a piece of the factory and then add more and more and more as you go to help build it up to the point where you built a model of the whole facility.
Yeah, we always see that with our other projects too. It's better to phase this thing out. You can have a big picture towards the end, but certainly start in phases is beneficial. You mentioned a little bit about healthcare. And I know for me, it's easy to look at discrete manufacturing and understand this process, but you dabble in other areas too, and you do it quite well. Like I said, not only healthcare, but also logistics and process manufacturing. Can you speak to some of the successes you've seen in those types of areas?
Yeah, like I said, I mentioned the healthcare one earlier, the hospital one, which is really a focus point for us at this time, because it's a very, let's take an example of that. Hospitals don't have a lot of engineers floating around to do modeling and that type of thing. So they need someone to come up and set up an infrastructure that they can take advantage of this technology, but not have to be model builders or, operations research people. So that's one good example of it. And oh, by the way, the beauty of that environment now is because of the laws that were put in place, electronic, data tracking systems are in place. They're putting a lot of RTLS and systems in that are actually, no kidding, tracking all that data. So that's very successful. Other places that we see, that are maybe more abstract. A lot of, be surprised, but even like retail, modeling of a retail facility, like a store where people come in and out, or a restaurant, or a fast food restaurant where people come out, where they're looking at things like seating, parking lot space. You'd be surprised at the different types of applications that come up in that area. Supply chain certainly is a big one, and supply chain analysis, looking at across all different types of industries. Warehousing is a big one. Did a lot with Home Depot and those guys, where they're constantly looking at the flows of things moving through their warehouses, and they're always looking at the fast movers versus the slow movers, and how to position things in the warehouses, how to redesign the warehouses. It was a good example. We worked with them, and they were talking about implementing a major change on one of their warehouses, which would have cost them, I don't know, about $2 million to do the changes. And they went in and built the model, and they found out it was going to hurt them, not help them. So it was like, ooh, probably not a good idea to spend that, millions of dollars on something that's going to make it worse, not better. So there's a lot of examples like that as well. I guess one other one maybe being the service industry, bank operations, backroom operations. So a lot of process, if you will, processing of different things like lockbox operations and things like that. But basically, it's all about a process where you have things flowing through, and resources and constraints that require you to understand what the capacity versus demand requirements are.
I live in a small home with my 2 daughters. I think I'm going to start modeling out the workflows here.
Modeling out sharing the bathroom.
Oh, boy.
I always like to ask, you've been around doing this for a long time. Is there a project that you're most proud of, or even a good story from the road type of thing? I think everybody that's been out, especially you've been in some incredible manufacturers. Anything stick out?
Yeah, I mean, there's lots of them, right? There's many of them. I think probably the one that resonates most recently is, like I said, Pfizer. We're pretty heavily involved in Pfizer, and with the whole COVID thing and manufacturing, we basically modeled their Kalamazoo facility, which they do all the vaccine production. So when everything hit the fan, it was like, oh, they already had models of the facility. So when they're looking at retooling the facility to be able to produce that vaccine, the COVID vaccine, that was huge. I mean, and what we're hearing from today is like, hey, man, we were able to meet our production rates and actually be able to give a good response on what we can produce and when, because we had models in place. So if that was something that they would have had to start from scratch, they certainly could have done it, but it would have taken them a few months to kind of get up to speed and have a model in place to be able to help them. But because they had most of that stuff already in place, they were able to turn it around very quickly. So that to us makes us feel good, where, hey, not only did we help, a company, meet their production goals, but we help a company push out a vaccine that helps save lives.
Mic drop right there. That's amazing. Yeah. And I think, the pandemic has really shined a spotlight on, being able to be agile and quick changeover. Look at all the manufacturers that all of a sudden, they're making windows, and, day 2, they're making, hand sanitizer. You've heard that, or carts to carry, breathing machines and what have you. So, that's incredible. And it's probably very rewarding to feel like you've had, some little piece to help a manufacturer respond faster.
Absolutely. Yes, for sure.
Nice. Well, so, for those that don't know, I was hoping maybe, Keith, you could give a little bit of a history on ProModel, and, tell our listeners a little bit about what ProModel is and has been doing for about 30 years.
Sure. Yeah. Over 30 years now. Well, it was, I guess it's a long story that I'll try to make short, but Dr. Harold, who's our founder, developed the first ProModel software back in the 80s, actually, while he was teaching, and still teaches at BYU. And he developed the first discrete event simulation engine in Turbo Pascal. So back then, if you go back that far, it was using simulation and modeling, and discrete event modeling was kind of a new art, if you will, where if you wanted to use it, you had a Fortran-like language, you'd go out and write some code in. And, that could take you a month or so to build a process. And typically it's a programmer, not an engineer. So it wouldn't be like a manufacturing industrial engineer, the guys that are really trying to figure out how to improve the processes or lay out manufacturing processes. So it was kind of difficult. So a lot of organizations didn't use it. Certainly the higher end ones did. And it, like I said, it took a lot of money, a lot of time. And oh, by the way, if you want an animation of that, you then pass the script off or the model off to an animator, and they would go in the back room and tie an animation to it. So extremely painful. So Charlie's concept from day one was to build an easy to use tool that could run on a basic computer. So back then, again, those high end ones had to run on a server type computer. And Charlie's, concept was it needs to run on an AT or an XT, an old IBM, whatever computer. So he started out, he built his first version that was extremely easy to use. It was actually very unique, where you go in and you type a simple little router in, say the part, here's my part, and it goes from machine 1 to machine 2 to machine 3. And then the program would actually say, okay, now define your icons for your machines. And you'd pick from a library and you drop the icons on the machine, and then you put it. So you would walk you through the model building process. And at the end, you'd run it and you'd get output reports. So it was designed to be low cost, easy to use, so manufacturing engineers could use it. So that was kind of the starting point that the company incorporated in '88 with Charlie and 2 of his students. I actually got involved in '89, where their first original business model was to have representatives. So they had representatives across the US and actually outside the US as well, that would train, support, market, sell, do everything except for develop the software. So their whole goal early on was just to develop the software and bring on a representative network. So that was kind of the maturity of the company for 10 years. So through the 90s, just using a representative network. In early 90 and 93, we actually then converted and developed the first Windows-based simulation engine. So right in, Windows 3.0, we developed the first true graphical user interface that you could then, drag and drop icons on the screen and build your model that way. So that is our main ship product. It still is around today, believe it or not, but it's had that many years of capabilities and customer requests built into it. So in the late 90s, we had a guy come in from GE who was then running the company, this guy, Pete Kalish, and his vision was, hey, that was, if you remember, before the .bomb, where companies were kind of scaling very quickly. So it was like, we need to get some outside revenue, outside venture funding of some sort to try to look at how we can grow this company. The vision was to bring all the representatives under the roof. So we had a big service component we could add. So the services on top of the software, as well as training centers, and set up, if you will, regional offices around the US and around the world. So we went through that whole process and had a merger actually in 2000, which didn't work out real well, and then kind of regrouped. So that was kind of our history. And then in 2002, we actually had Pfizer come in and actually interested in contribute a little bit of money to our organization as an investor, so that we would develop a tool for them, which was doing their portfolio management tool. So that's kind of the history. I would say then in the 2000s, we kind of took 2 routes. We have a route where we have our traditional commercial off-the-shelf software, which is our ProModel software, and our another process simulator software, and our AutoCAD version of our software. And then we have what we call mission critical applications, where we design an application that uses the same technology, but it's a pre-built, if you will, app specifically for an industry. So one is for healthcare that looks at, modeling of hospitals, and another one is for shipyards. And then we also had some Department of Defense stuff that we had built. So that's kind of the history where we are today. And recently, back in December, we actually sold off our defense business, which was more very specific for the DoD, for the Army Material Command used it, Forces Command used it to do Army scheduling and planning, and the Joint Forces Command uses our software to do a lot of mission analysis. We decided that was a good thing to spin off, because it was primarily more of a services type business. And our focus was now to really go toward more the software type business and really go all in on developing our software tools to the next level.
That's awesome. 1989, the year you started, was the year I graduated from high school, Keith.
Oh boy.
Well, Keith, I can't thank you enough. We're really excited about the partnership that you've developed with Autodesk and of course Applied Software. And thank you so much for sharing a little bit of time and the stories and your words of wisdom.
Thank you guys.
Yeah, it's been great.
Yeah. Thanks
Yes.
a lot, Keith. Next time I'm going to golf with you guys.
Yes, we'll have to get together on the golf course next time.
All right.
In New York, we can get together.
Yeah. Oh, that's even better. This is getting to the nice time of year.
There you go.
Yeah.
Sure.
All right.